Okay, we're going to look at what's called the ambiguous case for the sine law. When you're trying to find or solve a triangle and you're given three pieces of information, an angle, a side, and a side, well, you can use the sine law to solve that. The best law to solve for an angle, if you can, is the cosine law. But the sine law, if you have to use it and the angle is going to be obtuse, well, then you may have a bit of a problem. And this is why. So if you have, for example, the angle of 80 degrees, which is right here, and you take the sine of that angle, and you get sine 80 equals 0.98. Okay, so if that's 80, then sine of 80 equals 0.9848. If you take the sine of 100, okay, so there's 100 degrees. The sine of 100 that equals the same thing. Okay, so equals sine of 100 degrees. So if you've got a triangle and you're trying to solve for the angle and it happens to be obtuse and you're using the sine law and you get sine of theta equals 0.9848, well, if I do the sine inverse of that, okay, 0.9848, I'm only going to get 79.9, which is basically 80 degrees. Okay, so sine inverse of 0.9848 equals 80 degrees. It's not going to get me the 100 degrees back. So this is kind of like when you're dealing with quadratics. So if you want to find the inverse of a quadratic and you think that it's, y equals x squared, and you think that it's y equals the square root of x, well, that's only true when x is positive. It's not true when x is negative. Okay, so for example, if you have a basic quadratic and you've got 2 squared is 4, and you go up the other side and you go to -2, and -2 squared is 4. Okay, so when you square 2, you get 4. When you square -2, you get 4. Just like this. If you sine 80, you get 0.9848. If you sine 100, you get the same thing. But the square root of 4 only equals 2. So it only gets you back 2. Okay? And this is partly because of the CAST rule. So C-A-S-T. So all trig ratios are positive here, and sine is positive here. So sine is y over r, so y over r is going to be the same for both of those. And if you dealt with cos, well, cos is positive here but negative here. So cos of 80 degrees is going to be something, and then cos of 100 degrees is going to be the negative of that thing because cos is negative in this quadrant. So it's okay, you can find obtuse angles with cos inverse. You just can't find them with sine inverse. So this is what happens. So if we have a triangle, and say we've got the base here, and then we've got this angle, and the angle might be, I don't know, let's say 28 degrees. And this side length is 12. So I've only given you 2 pieces of information at this point. If I gave you a third piece of information, which would be this side here that I haven't closed in yet. Now this base length here, we don't know. I'm just drawing a line there where it could be. I'm just going to draw it right across. We don't know where it's going to end. Okay? So if I give you a length of 1 for this opposite side, it's probably not going to complete a triangle. If that's 12, this is probably not going to be 1. So the way we could find out the minimum length of this opposite side to 28 is if it's a right triangle. Okay, so the minimum length will be if that is straight down, and that's right. Well, we know how to solve for this side if it's not, or if it is a right triangle. We don't need the sine law. Okay, so the shortest length here is going to be, well, sine of 28, and we put x there, equals x over 12, because it's just sine equals opposite over hypotenuse. And x equals 12 sine 28 degrees, which then equals 5.63 approximately. Okay? So if this side length here is 5.63, then we have a triangle. Now if I gave you the list here, so say this is angle A, then this x would actually be side A. And then if this was either of the other two sides, but let's call this side B. So if I gave you the list of these numbers, so angle A equals 28 degrees, B equals 12, and A equals 5.63, then you'd have a triangle, and it would be a right triangle. And you could solve this with the sine law, and you would get this angle equal to 90 degrees. Okay? So how would you solve that with the sine law? Well, you would do sine of, you want to find this angle here, so this angle would be angle B. So sine of B over 12 equals sine of 28 over 5.63. Okay? And when you get that, you would have angle B, and you solve that, you'd have angle B equal to 90 degrees. So it's solvable. You get one triangle. What if I gave you a list where the side length, or the angle is still 28, so angle is 28 degrees, angle A is 28 degrees, side A equals 7 units, and B is still 12. Okay, so if I was to draw that, I'd have a line going across the bottom there. So there's 12, 28 degrees. Now the angle hasn't changed, so the diagram is going to look somewhat like this one. So I'm just going to put the dotted line in. That would have been 5.63 if it had been a right triangle, but it can't be because A is too big. A is not 5.63, it's too long, so we're not going to go straight down. You would go right through. So in order to make it that side 7, we have to put it out here. Okay, so there's 7. Now the thing is, we have another option. The option is that could have been 7 there. So this is where we have the ambiguous case. We have the case where if you're given these pieces of information, angle A is 28 degrees, side A is 7, and B is 12, your calculator, because it only gives you angles, the sine inverse only gives you angles between 0 and 90, it will only give you this angle in here. Okay, and you can try it. So you can do, so that's going to be vertex B. So sine B over 12 equals sine 28 over 7. So B equals sine inverse of 12 sine 28 degrees over 7. You plug that into your calculator, So second sine inverse of 12 times sine 28 divided by 7, close the brackets, and that gives you an angle of 53.6 degrees. Okay? So that gives me this angle here. Now, your calculator won't give you this other angle over here because it's greater than 90. So what you have to do is recognize that this angle B here is the same as this. And the total of these angles here add up to 180. All right? So I'm going to call, this is B as well. That one is going to be equal to 180 minus 53.6 degrees. Okay. And that would be 126.4. Okay. So 126.4 degrees would be that one. So we don't know which triangle it is. So in this case, when you're given these three pieces of information, it's an ambiguous case. You can't tell which triangle it is. You have two options. Okay? Now, so the first case is basically, if we look back here, if A is less than 5.63, you don't have a triangle. It's too short. If A is 5.63, then you have one triangle and it's a right triangle. If A is bigger than 5.63, then we seem to have two triangles. So that's case 3. A fourth case, though, would be this. What if angle A equals 28 degrees, side A equals 14, and B equals 12? Now when you draw this picture, you're going to have the same angle. So draw that side out there again. 28 degrees, 12. And that's the line straight down. Okay? But this side over here, okay? So this side over here, side A, is now 14. It's bigger than 12. So it's going to go like that. 14. And because this side is longer than 12, we can only have one triangle again. Okay? So this is our fourth case where this side, opposite to the angle that's given, is bigger than the other side. If it's bigger, then we don't have an ambiguous case anymore, because we can't flip this over and fit one in here that's longer than that. Okay, so we have 4 cases now. Okay, and this is like a diagram that would show you what's going on. Okay, so this is the shortest side. This is when A is bigger than C sine A, but less than C. So A is, okay, it's bigger than this shortest side. So C sine A is this shortest side. And then when A is bigger than this opposite side, this side here, then you only have one case. All right, so this is one case. This is 2 cases here, the 2 A's. And this is back to one case when it's a right triangle. And then there'd be no case if it wasn't big enough, if A was less than C sine A. Okay, so we have, these are the cases. Okay, and that's it for the ambiguous case.